We're now looking at the process of finding the variance from a set of numbers. This is the overall formula that we'll be using. The sample variance, or S squared, will be equal to the summation of each individual x point minus the mean, quantity squared, divided by n minus 1. So the first thing we're going to need to do is find the mean. To do that, I'm going to add together each of these, 10 plus 8 plus 7 plus 10 plus 5, and divide by how many numbers there are, in this case 5. When I added those all in my calculator, I got 40. 40 divided by 5 gave me a mean of 8. When I'm now trying to calculate the sample variance, I'm going to take that mean of 8 and subtract it from each data point. So the first data point is 10. I'm going to subtract 8 from it. I'm going to do the same with the next data point and keep going until I've done it for every data point. Except instead of just taking the differences, I'm going to square the result. Really, the reason for that is to make them all positive differences so they can find on average how far is a data point from the mean. So I'm going to put a squared over each of these to say that I'm going to square the result. When I do 10 minus 8, I get 2. 2 squared is 4. 8 minus 8 is 0. 0 squared is 0. 7 minus 8 is negative 1. Because it's being squared, it's going to become positive. At this stage, when I'm finding square distances, I should always get positive answers. So negative 1 squared gives me 1. 2 squared gives me 4. Negative 3 squared gives me positive 9. We've now done each individual part on top here of the formula, but this symbol means that I need to add them all together. So I need to take the sum of each of these squared distances. 4 plus 0 is 4, plus 1 is 5, plus 4 is 9, plus 9 is 18. So I now have the entire top of the fraction, the sum of the squared distances. If I take the top of that fraction, 18, divide it by how many data points I had, in this case 5 data points, and subtract 1 because it's from a sample, that becomes 18 over 4, which should give me 4.5. What that 4.5 represents is the variance for this distribution. What I did here was use the definition formula. Really, I only like to teach it that way. There's a computing formula that involves squaring the mean, taking it away from the sum of the different data points. You square them. It's a slightly different formula that some people find easier and is in the book. My issue is when I've taught it both ways, students get confused between the two formulas. Really, this definition version comes up as part of the next unit when we're doing probability, so I prefer just to stick with that and not even mess with the second version. For that reason, I'm just going to copy down this answer of 4.5 for what I would get using the computing formula. The truth is both formulas end up the same place, so any answer I get with the first will be the correct answer for the second. When I now am asked to calculate the standard deviation, basically all that means is we have s squared. If we take the square root of it, we can get back to s. So we have s squared is 4.5. If s squared equals 4.5, then s equals the root of 4.5. When I put that into my calculator says that the root of 4.5 is 2.12132. It says to round to 3 decimal places. Here's 3 decimal places. The first number that I would drop would be a 3. Since that's less than 5, I can just drop it and report my answer as 2.121. If this had been a 9, for instance, I'd report my answer as 2.122.